Hello and welcome to Biorules Visual Lessons. Now that you saw a little bit about our nervous system and about our endocrine system that work together to do the coordination, we are going to see how our body controls our body conditions. Of course, when you think about coordination, we think about thinking, about running and hunting and dancing. But when we think about coordination as well, one of the most important part of the coordination system in our body is to maintain the internal conditions of our body constant. We need to maintain the oxygen and carbon dioxide constant in our body. We need to keep the glucose constant in our body. We need to keep the temperature constant, the water levels constant, and so on. So all this maintenance is done by our coordination systems, which is the nervous system is going to have a very big role on that. Our endocrine system have a role on many of these functions as well. So let's take a look on how they do this. And for a start, when you're talking about keeping conditions constant, we are going to be talking about feedback. We are going to be talking about actually negative feedback. We discussed negative feedback a little bit when we were talking about enzymes, but now let's take a little bit deeper look on the idea of negative feedback. The negative feedback is that when you have a condition that should be the norm, that should be the standard, if you have an excess, if you have an increase, if you have something that is above the norm, you trigger corrective mechanism, something that's going to say, hey, let's make it to go back down into norm. And if you have a deficiency, if it goes down, if you have it too low, then you have a corrective mechanism that say, hey, let's make it to go up. So basically, negative feedback, the idea is that if it's too high, push it down. If it's too low, push it up. So, or we can say the more you have, make something to have less. The less you have, make something to have more. So the more, the less, the more. The higher, the lower, the higher. So basically, it's to push in the opposite direction to make things go back to the norm, to the standards. Okay, so this here is the idea of negative feedback. Okay, one classic example of negative feedback system is a water tank. If you have seen a water tank working, it has a tube that throws water, let's make water here in blue, that throws water here, and the water levels start going up, all that stuff. And if you don't stop it, it ends up overflowing and it gets out. So to avoid overflowing, the tanks, they have this buoy over here that when the tank is full, this buoy moves up and this stuff here ends up closing here the water pipe and the water stops flowing. When the water is down, this buoy is down over there and this lever here ends up opening the water and then the water goes over there. So the more water you have, more this buoy closes the water pipe and stops the water from flowing. The less water you have, more it opens the water pipe and more water goes. So the more water, less water, the less water, more water inside. So this is a classic functioning of negative feedback system and mechanic system. If you have a toilet in your house that has this kind of box, I strongly advise you open it, take a look inside. This is negative feedback. Okay, it's very easy to see. So that's the idea. We have there the tube, and when the buoy goes up, it blocks the water flow. So negative, the more, the less. Okay. Another example of negative feedback is on radiators in cars. So a radiator in car is a structure that cools down water that flows around the car. So we have here a system showing the water flowing around this pipe, so it can flow over here or it can flow over here. So basically the water can flow in different places over there, passing through the engine. If the engine is cold, this sensor over here says, hey, let's not pass this through the radiator. So basically what's going to be doing is to let the water to flow directly here, engine. So because the engine is hot, this ends up warming up this water. If the water starts becoming too hot, then you say, no, not a good idea. Let's pass it through the radiator. So let's make it go. So you close over there and make it flow through the radiator so the radiator cools it down. So the engines, it warms up very fast because while it's kind of cold, the engine itself, the sensor over there, makes that the water is not going to be flowing to the cooling system, and therefore it warms up faster. Another example of this is when you have an air conditioning. Air conditioning you set up there for a certain temperature, like in our room here, we set it up for 23 degrees Celsius. If it's too hot, if it's 24, 25, 26, then it starts turning it on and it starts cooling down and makes throwing out cold air. And that cold air is going to make the air to go from 25 to 24 to 23. It reaches 23, oh man, the 20 to 22, 21, oh, it's too cold now. If it's too cold, then it's going to be warm it up. Some of these air conditionings, they don't warm up, they just stop cooling down and they let the room to warm up by itself. But some air conditioners will even turn on the heating. So it's 21, the air conditioning overcompensated, okay, turn on the heating, make the room to become warmer. Hey, 21, 22, 23, now it's good. 24, no, cool it down again. 24, 23, 22, no, warm up again. So the air conditioner stays keeping the temperature. No, the hotter it is, make it colder. The colder it is, make it hotter. This is a classic system of negative feedback. Okay. Another system that works with negative feedback, we saw this in biochemistry, is the working of enzymes by inhibitors. If you have a lot of the production, for example, here you have the threonine, which is the end product of this metabolic pathway over here. The threonine may end up going to an allosteric site, blocking the enzyme. And if the enzyme is blocked, it stops the production of the first intermediate over here. And then you start accumulating aspartate because you have way too much threonine. If you start running out of threonine, so let's run out of threonine, you stop inhibiting the enzyme. If you stop inhibiting the enzyme, you stop blocking it in here, then you restart producing, and then you make more threonine. So too much threonine, stop making threonine. Too little threonine, make threonine. Classic negative feedback through enzymes, competitive or non-competitive inhibition. In this case here, this is a non-competitive inhibition or allosteric inhibition. Okay, so the idea, let's put things here together. The idea is you have a standard, you have a norm. If it goes up, react. Your nervous system, your endocrine system, they are going to be making something to make it go down. If it's too low, react, and your body systems, the nerve system, the endocrine system are going to react and make it go up. So the higher, the lower, the higher. This here is the idea. Just to illustrate this here now for you, let's take a look on control of one characteristics in your body temperature. So you have a certain body temperature. In human beings, the norm for body temperature in the core is 37 degrees Celsius. If you measure in the skin, it's going to be 36 point something. But if you measure on your ear, it's going to be almost 37. If you measure the inside of your core, it should be 37 degrees Celsius. So 37 is the norm. If it starts becoming too high, so basically, if the temperature is too high, you're going to have a piece there in your brain, in your hypothalamus, that's going to be sending information, hey, make something to push the temperature down. If the temperature is too low, you're going to have the same sensors in your hypothalamus there. They're going to say, hey, push it and make it to go high. So basically, temperature is controlled with the sensors. They are in your skin, in your brain, and they are going to send the information to your hypothalamus to say, hey, let's work this temperature here. If it's too cold, one thing that your body will do is to shiver. You start shivering, and by shivering you produce movement, and a byproduct of movement is heat, and then you warm up your body. Okay, and if you're warm, the classic reaction of body when it's warm is for you to sweat. You have water going to the surface of your skin. This water evaporates, and when it evaporates, because of this high specific heat capacity of water, it carries heat away and cools you down. Two things that we do to regulate our temperature: to shiver, to warm ourselves up, and to sweat, to cool our bodies down. Actually, there's more about that. I have here a diagram illustrating this. Another thing, so we have here the sweat. When it's too hot, you sweat to make it to go down. Okay, if it's too cold, you shiver to make the temperature to go up. But there's another thing that we do as well. If it's too hot, the arterioles taking blood through our skin, they can vasodilate. You see here this image compared to this one over here. The one in the top, the blood vessels, the arterioles, they are a little bit more enlarged. So they vasodilate, they let more blood flow towards the surface of the skin. So if blood flows more towards the surface of the skin, the blood receives hot, the blood that contains heat, contains hot water over there, gets closer to the surface that usually in our planet is below body temperature, and then it cools down our body. So if you are in a place that's below 30 degrees Celsius, when you vasodilate, you move heat to the surface of your skin, and then you lose that heat. The opposite happens when it's too cold. Oh, by the way, sorry, when that happens, it's common that you get red. Some people, when they start running, they overheat, because when you run, you heat a lot, you start sweating. And some people, they show very clearly blushing, they become a little bit reddish. That's vasodilating, showing up on the face, that they are vasodilating to take the blood to the surface of the skin to cool it down. The opposite happens when it's too cold. If it's too cold, you have vasoconstriction. The blood vessels, they narrow down, they reduce the blood flow to the skin, and then you don't take your very valuable heat to the surface of your skin where heat is being lost. So you avoid losing heat. And people that sometimes feel very cold, especially children when they go swimming, is that they become, with some parts of the body that are supposed to be reddish, like the lips or the bottom of the nails, they start becoming bluish. So we say, oh, look, the skin is blue because less blood is flowing there, and then you feel this pain. That's the mechanism of the body trying to control the temperature. Okay, so we have all these guys over here working. Okay, and again, if it's too cold, so you can vasoconstrict. In that case, you keep the warm inside of you. If it's too hot, you can vasodilate, and then you send the warmth outside of your body. Here we have an example showing that we have systems of arterioles and veins and capillaries close to your skin. We have a more in-depth arterioles in here, but we also have little artery that can carry blood to the surface or not. If it's too cold, there is a vasoconstriction here, and then the blood don't flow much closer to the surface. The blood stays a little bit deeper. If it's too warm, then you vasodilate, and the blood flows closer to the surface, and then loss is you have the loss of heat by radiation. Okay. Again, another image here for you to see this in a little bit more real life diagram. You have in-depth blood vessels and you have superficial blood vessels, and the idea here is to vasoconstrict these guys here when it's too cold and vasodilate them when it is too hot. This is the way that you control body temperature in our skin. In addition, of course, to shivering if it's too cold, sweating if it's too hot. And another thing that can change as well is your metabolism. If it's too hot, we can lower down our metabolism. So That's why sometimes in very hot days we feel kind of lazy, we feel kind of tired, because a negative feedback mechanism tells our body, hey, slow down the metabolism, it's too hot, it's not good for us to be too active. And if it's cold, then you become a little bit more alert, and you do the opposite. You send a signal to your body, say, hey, let's start moving around, be a little bit more active. That's why teachers love our conditioning. We love our conditioning because if the classroom is too hot, kids get lazy, kids get tired, and because the metabolism goes down. It's not the fault, it's the thyroid telling the body, hey, slow down. That's why we turn on the air conditioning. If it's cold, then you avoid that mechanism, your metabolism goes high, and say, hey, let's learn. That's the idea of turning on the air conditioning in the classroom. Okay, so here we have two examples. We can very clearly see the core here. On the core, the temperature is always going to be 37 degrees Celsius. No matter what, the temperature is 37. But if you're feeling cold, if the air temperature is cold outside, so for example 19 degrees Celsius, you are going to be reducing the blood flow to extremities, and then you're not going to be losing much heat through your extremities, especially through the face, through the arms and legs. People that feel cold, sometimes they have cold feet. If your feet are cold, it's not that the outside is making your feet to be cold. Actually, it's your body making something to avoid heating up your feet and say, hey, it's just the feet, let it get cold, not that important. Let's keep the heat inside here of the noble part, in the brain, in the heart, in the thorax. That's the part that should be kept at 37 degrees Celsius all the time. If you have a problem that the core temperature drops from 37, then you are going in the direction of have hypothermia. If you have ever started shivering, you had a pre-hypothermia, so you went in the direction of hypothermia. But hypothermia actually is more serious than that, and in the first aid course we are going to be discussing this more in details. Okay, the same goes here. If you start getting too hot, then your body is going to be sending all the blood they can to the extremities to try to send all the heat away. So you evaporate the water, the sweat glands are going to be making heat to go away, to cool down. Because if the body temperature, the core temperature gets much above 37 degrees Celsius, you may have a problem as well, and you can have a heat stroke, and that can be bad. A too high temperature is something that can be very, very dangerous, as well as a too cold temperature. The hypothermia is as dangerous as a hyperthermia. We'll see this in the first aid course, so you learn how to deal with these conditions. Okay, just putting everything together here. If you have the temperature that have been decreased, you have to signal, and you're going to have shivering, you're going to have an increased metabolic rate, you're going to have vasoconstriction to avoid blood going to the surface. So you may even have your hairs around your body raised. There is a little muscle connected to the bottom of the hair that if it contracts, it's make your hair to go up. Not very efficient in humans because we don't have much hair around our body anymore, but if it's too cold, you feel the goosebumps. The opposite, if the temperature is too high, if the temperature has been increased, then you're going to do the opposite. The hairs are going to be lowered, you're going to start sweating, you decrease the metabolic rate, so you're going to become lazy, and you're going to have vasodilation, send blood toward the surface of your skin. So this is the idea that you have over there. So this is the putting things together on how we control things, okay? And this is the star of the show when you talk about controlling body temperature, the hypothalamus. The hypothalamus is going to be doing lots of stuff. You're going to see in physiology in the next classes that there are many things that the hypothalamus control. If someone asks you, okay, who controls this? If you make a guess on hypothalamus, there's a big chance you're going to be guessing it right, because hypothalamus is responsible for controlling many stuff in your body, and it controls your body temperature as well. Okay, so now take your time to do this little quiz, answering some questions, and I'll see you in class. Bye-bye.